Good morning, and thank you for attending our presentation today. My name is Silvia Dominguez. I'm a research associate at Laval University, and I'll be giving this talk with my colleague Noura Braham from Tunisia. During this talk, we will present a methodology for converting food expenditure data from household budget surveys into food consumption data. In the first part, I will describe the data transformation steps to go from the amount a household spends in food to the amount of food consumed by an adult equivalent. And next, Noura will explain how an adaptation of this methodology was applied in Tunisia. Food expenditure data collected in household budget surveys is data in monetary value, so for example in dollars, representing the amount a given household spends in different food items in a given time frame, so for example in 1 week. When food consumption data is needed, like for chemical exposure assessment or for total diet studies, information collected via specialized methods such as 24-hour dietary recalls is the gold standard. But they're not always available, and conducting this kind of study is costly and time-consuming. On the other hand, in many countries, recent household budget surveys are readily available, and using this expenditure data is quicker and more cost-effective than directly collecting food consumption data. As you will see in the following slides, using data from household budget surveys is not necessarily straightforward. In terms of data requirements, the most important thing is to have access to the survey's raw data. So specifically, the composition of each household, so the age and gender of each member, and the amount spent in food per household, not just the mean amount spent by the entire population. Information not from the survey itself is also needed. For example, the items listed in the green bullet points that I will explain in more detail in the next slides. So let's start with the data transformation steps. An important concept here is the adult male equivalent, or AME. A limitation of the household budget surveys is that they provide expenditure data for an entire household, and we cannot know what portion of the expenditure corresponds to each individual. To overcome this limitation, we can express household composition in terms of the energy needs of a reference individual, which is what we call the AME. An AME is based on the energy needs of an adult male. The energy needs of other age and gender groups are then expressed as fractions of this reference value. Standard energy needs per age and gender are available from various sources. This, for example, is a table from the United States. If we look at male, moderately active, and age between 26 and 40, we see that the estimated energy need is 2,600 calories. You can use this as your AME, or you could also choose a different table, perhaps something more specific to your country. Once you select the energy needs that you will, the energy needs data that you will use, you can build a table of AMEs for all age and gender groups in your population by dividing each group's energy needs by the AME. Here you can see for male between 26 and 45 years old, this is a reference value with an AME equal to 1. And then, for example, for a 2-year-old boy, this would be 0.38 of the AME. This conversion will allow us to express household composition in standardized units. So as I said earlier, having access to the survey's raw data is critical. In this very simplified table, I'm listing a hypothetic number of households in the first column, and next to it, the breakdown of the household members. So HH1, which would be like household 1, is made of 1 2-year-old boy and 1 adult male. If we use the AME from the previous slide, this represents 0.38 AME for the boy and 1 for the adult male. And then we add the values to obtain the total AME for the household. So from now on, the composition of the household is expressed as AME. The second step is much simpler. Household budget surveys track food expenditure in a specific time frame. So if the survey is based on a 2-week period, dividing the amount spent per food item per household by 14, we'll transform the data into a per day basis, which is what we want. Now let's start with the steps needed to go from food expenditure to food consumption. So from the amount of money spent in food into grams or milliliters of food consumed. The first thing we need to know is the price of food in this specific country. This information may be obtained locally or from international organizations. Something to note here are the units used to report the price of food. For example, this could be in grams, or per 100 grams, or per unit of food, etc. So to avoid mistakes, it is recommended to generate a price per food reference table where the price per unit of each food included in the survey is listed. In previous steps, we converted food expenditure into the amount spent per household per day for each food item. We now know how much each unit of food costs, so we can calculate the amount of food purchased by each household by dividing the amount spent per day by the cost of a unit of food. And now we have an amount of food consumed in grams or milliliters or other units, but we're still at the household level, not the individual level. So to recapitulate, earlier, we calculated the number of AMEs per household, and then we calculated the amount of food consumed per household per day. Logically, what we'll do next is use this information to estimate the amount of food consumed per AME per day. Specifically, we will divide the amount of each food consumed per household per day by the number of AMEs in the household to obtain the amount consumed per AME per day for each household. And now we finally have transformed expenditure data into individual food consumption data. But there are still a few more adjustments to make this information as accurate as possible. For some foods, like milk or bread, for example, the amount consumed is equal to the amount purchased. But for other food items, like bananas or eggs, the amount of food consumed is not necessarily the same as the amount purchased because of peeling or cooking. This is something that needs to be taken into account. This is a very important step, actually, but it may be time-consuming. Some conversion factors are available in the literature, but others may need to be determined experimentally. In this example, rice is transformed using two factors to account for presence of dirt in the raw material and water gained during cooking. After this conversion, the amount of rice per AME per day went from 10 grams to almost 30, which is quite an important increase. And lastly, to work only with the most representative data, we need to exclude over and under consumption values. This can be done based on the amount of energy each estimated food consumption represents. For example, consumptions above a given energy threshold could be considered overconsumers and filtered out. To do this, we need to know the amount of energy per unit of food. Since the food included in the survey is most likely specific to the country or region, it would be ideal to use a food composition table including this type of food. In this example, we have Braham's food composition table, which expresses energy in kilocalories per 100 grams of the edible part of the food. So again, we need to pay attention to the units. Like we did for food prices, it is recommended to create a reference table, including the energy per unit of every food in the survey, like the very simplified example I'm showing here. And finally, we will calculate the energy provided by every food item consumed, add up the values, and obtain a total energy intake per AME per day, shown here in the last column. Extreme values can then be removed. For example, those below 1,200 or those above 5,100. But note that this is just an example and local or regional values may vary. As I mentioned at the beginning, using food expenditure data as surrogate for consumption is not straightforward. But after all these transformations, we have data representative of individual food consumption that we can work with. In most cases, this will be a very large data set where per every household in the survey and per every food, we will have an estimated amount consumed per AME per day. This data can then be used, for example, for exposure assessment, since we'll have a distribution of consumption, not just the mean value, or in total diet studies when selecting the foods to analyze. And that was the theoretical part of our talk. My colleague Noura will now continue presenting the Tunisian experience. So, Noura.
Thank you, Silvia. My colleague presented to you the theory. I will give a practical example with the Tunisian experience in food consumption survey. In Tunisia, we have a national food consumption survey, which is part of the national household budget consumption and standard of living survey realized by our National Institute of Statistics. This national household survey was initiated in 1968 and became a 5-year survey. Actually, this survey includes 3 components. One about annual household expenditure, the second about the food consumption in terms of quantities consumed, the last one about access to community service. Let us have a focus on the food consumption survey. The National Food Consumption Survey, realized by our National Institute of Statistics, is not a household expenditure survey. It does not estimate the amount of money spent for food. It estimates the real amount of food consumed in a household. In this survey, the food unit is all the people who depend on a single center for most of their food. And during 7 consecutive days, the investigator goes twice a day and notes the menu of each main meal. At each visit, he weights the quantities of food intended for direct consumption or which constitute the ingredients in the preparation of meals. The investigator also notes the number of people who attend the meal. He evaluates what is left of each meal and even quantities of dishes there were offered. The amount of food consumed is reported to people who actually consumed it. It's a ration count. In 2009, the National Agency of Sanitary and Environmental Control of Products carried out the first Tunisian total diet study. One of the most important components of this study was the collect of food consumption data needed to identify food to be tested and to estimate the exposure. We did not find food consumption survey at national level. The conduction of a national food consumption survey at individual level needs a lot of time and money, and we found that the National Food Consumption Survey of our National Institute of Statistics have many positive points and can be used in our total diet study. First, the household sample was representative of the Tunisian population. Second one, the food consumption survey of the National Institute of Statistics cover all the years. So we can have an idea about all the variation of the food consumption during the years. And this survey estimates the real amount of food consumed, and the food were weighted as purchased or in edible state. So the National Agency of Sanitary and Environmental Control of Products established a cooperation with the National Institute of Statistics in order to have raw data from this study. The National Institute of Statistics gave to the TDS team raw data of its consumption survey. The disadvantage of this survey was that the data were at household level, so we asked to have the household composition, the number of individuals, their age, their sex, their weight, and their height in order to convert the household to an adult male equivalent. The observation period was 1 week, so we asked to have the data consumption in grams per week per household of food as per session. And we knew that for a subsample of the survey, the investigators weighed food before and after preparation, and that the National Institute of Statistics have real national edible factor, so we asked to have it. The first step of the consumption data transformation was the conversion of the food quantities as purchased to quantities without the inedible parts. For this conversion, we used the inedible factor of our National Institute of Statistics. And in case of where there was not the corresponding factor, we referred for international tables, and if there were more than one value for the same food item, we calculate and use the average of the different values. If there is no corresponding factor in the international table, we do experimental study and we estimate the edible factor for this food. The second step of this transformation was the conversion from food quantity as prepared without the inedible part to food quantities as consumed. And for this conversion, we used yield factors. In this case, we have no national yield factor, and we refer to international tables that present yield factor for different kind of cooking methods. And if we have more than one value for one items and one method of cooking, we estimate the average and use the average in your conversion. If there is no factor in the international table, we do experimental study and we establish national edible factor for this kind of food that cannot be found in international tables. For the data treatment from household to adult male equivalent, we used an international table that we found in the FAO WHO report, and you can see in this slide the value for individual depending on their age and on their sex. So, for example, for a young child from 2 to 3 years, if there is a boy, the factor was 0.45, and the same for a girl. And you can see that in these tables, the adult male equivalent that have a factor equal to 1 is a man from 19 to 50 years. After the transformation of the data consumption from household to adult male equivalent, we identify and eliminate outliers. And for this, we estimate the energy intake for each adult male equivalent of the subsample that had been given by the National Institute of Statistics to our teams. The average energy intake of the subsample of 420 adult male equivalent was 2,745 kilocalories by day. And we decided that we will eliminate all the adult male equivalent that have an energy intake above mean plus 3 standard deviation. It was almost 6,000 kilocalories per day. So we eliminate 8 outliers that have an energy intake from 6,000 kilocalories per day to more than 9,000 kilocalories per day. At the end, we used the 412 adult male equivalent for the estimation of the food consumption. And with this subsample, we have a consumption distribution that we use it for data consumption. And you can see in these tables the data consumption that we use to estimate the expenditure of the Tunisian adult population. So with these subsamples of 412, we have a distribution, and for each food item, we have the percentage of consumer, the average consumption, the total intake consumption. We can have maximum, median, standard deviation, the 5th percentile, and the 19th percentile that were used in the estimate of the Tunisian adult exposure. The only disadvantage of this kind of data is that when you estimate the exposure, you can only have conclusion for the adult population. In this case, the results were only for adult Tunisian population, or all our conclusion in this total data study were for adult Tunisian population. We cannot extrapolate for at-risk population like children or pregnant women or elderly or other kind of at-risk population. So we decided that in the next step, we will conduct an individual food consumption survey for children in order to be able to estimate exposure for children, for example. So the conclusion of this Tunisian experience is that the use of food consumption data from expenditure or consumption survey related to a household can be a useful tool to estimate exposure assessment, but that this tool is limited and cannot help us to evaluate exposure for all the population and for the at-risk population. Thank you for your attention.
I join Noura in thanking you for attending our presentation, and we hope you enjoyed it.